Know what the word mono means? That prefix it means one. It means one. Voice off, guys. Guys. Thank you. Mono means one. Justin. Thank you. Mono means one. Okay, it's a prefix that means one. So monomial is just going to be one term. So mathematically, we talked about how we had different terms. We talked about combining like terms, multiple terms, all these different things. Monomial is just going to be only one term. It means there's just one term. So we're going to learn some rules about dividing those. Now we've already technically divided some monomials. Even if you just do the fraction 3 over 2 or 4 over 2, that's a monomial. You don't have to write this part down real quick. But if you even just have the fraction 4 over 2, no, it's just it's just as long as there's just one term. So a monomial, 5 is a monomial, 2 is a monomial, x squared is a monomial. It's just one term. But like an example of one that wouldn't be, don't write these down, would be like x plus y. Whenever it's at that plus sign, or 5 minus 2, whenever there's the plus or minus sign, that's when it changes.
So it's just like one thing.
Yep.
And if it's something separating it, then it's
yep. Exactly right. So on this, we're going to do some exploration with some more exponent rules. We learned exponent rules on Wednesday in this class. We learned some exponent rules. And we talked about, I just the major one. I didn't realize I was signing up for the intense one. We learned different exponent rules that we talked about during our warm-up today and also during our homework. So the exponent rules we learned were about our when to add the exponents, when to multiply the exponents, and whatnot. Like when we multiply terms and when we have terms raised to a different power. So today and on Monday and Tuesday of next week, depending on the class you have with me, because this video is also for second hour. Depending on when you have me, we'll be learning more about this lesson as well. But we'll start out today. When we divide monomials, we're going to really subtract the exponent. So when we have the powers with the same base, once again the same base a, so when we multiply, they had to have the same base, we subtract the exponents. We're going to subtract those exponents. We're going to subtract the exponents. And there's a couple ways we can kind of think about this to help it kind of clarify. One way is, what did we do when we multiplied? When we multiplied like a to the m times n a to the a to the n, what did we do with those exponents? We added them. Well, what's the opposite of multiplication? Division. And what's the opposite of addition? Subtraction. So does it make sense when we do the opposite of multiplication by dividing, we would do the opposite of adding, which is subtracting? Okay, I think it does make some sense for us. So for an exploration here, I want us to do this one. So this part I want you to write down. A to the 6th over a squared. A to the 6th over a squared, divided by a squared. That's all a fraction is a division problem. Just go and write that down. Do you have pencils? Oh, that's very nice of you. Thank you. A to the 6th is really like 6 a's being multiplied together, correct? So we could write a times a times a times a times a times a. What would the bottom look like then? Just a times a, right? Now in fractions, what can we do with those? We can start dividing them out, right, Ben and right, Grace? Okay? We can start dividing them out. We don't want to say cancel, because cancel gives us the thought that it goes to 0. But it actually, what happens when you divide anything by itself? You get what number? 1. So it doesn't. So we don't want to say cancel. I say divide out. It's a little just bit of a different word. I just like to call it divide out. So we can divide out 1a and 1a, right? Could we divide out 2 a's for this one? No, we had to go part by part. So how many more a's can I divide out of the top? One, and had to do this one on the bottom, right? So what am I left with on the bottom? What number?
0.
What's a divided by a? 1. What's a divided by a? 1. So what number am I left with on the bottom? 1 times 1 is 1. And what am I left with on the top? 1 times 1 times 4 a's being multiplied together. So just a to the 4th and just 1 on the bottom. Isn't that the same thing as just a to the 4th? What would have happened if I took a to the 6th and a to the 2nd and I divided the 6 minus 2? Or I subtracted 6 minus 2, excuse me. If I did 6 minus 2, 4. Would I get the same thing if I did this rule that we just kind of talked about? Yeah, I get the same thing. So this is the math behind why it works. So if on a test or something like that you get stuck, you don't remember these rules, you can write this out. That's what it literally means. You can write it out and divide it, and you'll still get the same answer. And that's one way you can also help you to remember the rules. When I was first learning these, that's something I would do. It'd be like, okay, what do I do here? Do I subtract? Do I multiply? Do I add? What do I do with these exponents? I would write it out and remember, oh yeah, I divide. Because when I put this way, I'd be like, oh, okay, I remember this. I know how to divide these. And we would get this. Grace.
So if it was like 8a to the 6th and then like 4a to the 2nd, would you be able to, you just subtract 8 by 4?
You would still divide those numbers normally. So this is just for the exponents. So this is just for our exponents with the same base. So we would divide the numbers normally. Good question. All right. Any other questions before we start doing some examples over this? Okay. The first one, s to the 3rd, s to the 2nd. Do we have the same base? Remember, base is what's being raised to the exponent. Yeah, we do. Base is at the bottom, okay? So we have the same base s. So we're dividing powers with the same base, right? So what's it say we do with the exponents? Subtract. So it's going to be s to the 3 minus 2, top minus the bottom, which ends up being what? Just s to the 1st, or s, right? On the second one, we have a bit more going on. But we still have this all being multiplied together, right? We don't have it separated by like a plus or minus sign anywhere in here. No, we don't. Okay. So this is all being multiplied together. So now instead of multiplying these two parts, we're dividing these two parts. So are we still dividing powers, but some of these have the same base? Yeah. So what are we going to do? We're going to go step by step through. We say, okay, with the x's. Can we do anything with the x's? Yeah. What do we make x to the 3rd? Because 5 minus 2, x to the 5 minus 2. What do we do with the y's? We do y to the 3 minus 1, and we get y to the 2nd. And do we have z with anything down here? So you just have the z because it didn't divide by anything.
So if you would have like z over z, would it just be nothing?
Correct. It would just divide to 1, which you don't write.
One is just.
So Graydon asked a good question, and I want to talk about it. It's just kind of an extra question on this. So I'm going to write it in a different color because it's an extra question. You don't have to write this part. Graydon asked, what if we had z down here in addition? What would we put? Well, the z and the z would just divide out here, and you'd end up having just 1. You end up just having 1. That was just an extra question Graydon asked.
So you wouldn't like put z because it gets.
Because they would divide out, yep. Yep, if there was a z there, that's what would happen. If not, but if there was, that's what happened. Just like if you had 4 over 4, you don't write 4 anymore, you just write 1. Same idea. Any other questions on the first two before we move on to the third? Okay, on the third one, are we dividing powers with the same base? Yeah, so what are we going to do with the exponents? Subtract them. So something I end up doing here is I say, okay, are we going to get rid of all of these b's down here in the bottom? Because technically there's 4 different b's being multiplied together. Are we going to get rid of all of them? Yeah, because the number on top is bigger, right? So one thing I do is I say, okay, just like when we divide and simplify, and it's like if I were to simplify here, up here when I simplified, I still slashed them out and put what it was in place of it. What's going to be in place of all these b to the 4th? 1. And b to the 14th is, am I still going to have some b's on the top? Yeah, so I'm not going to cross out the b, but I'm going to cross out the exponent. And what's this exponent going to become? 10. How'd you get that? 14 minus 4. We still do that. So this is something that I'll transition to doing on all of these, but I just started without it and I added it in as we got more comfortable. So we'll end up having our answer be b to the 10th over 1, which is just b to the 10th, correct? Because anything over 1,
over one thing or
we don't have to write over 1 now. Nope. But when we divide out, I just put the 1 there to say, oh, it divided, okay, I simplified it. Let's write what's left, just that way I keep a mental track. Just like up here, keep a mental track, just keep things organized. Good question. Any other questions on these 3? Okay, we're actually going to call that good for today. We're going to call that good for today. Nope.
Thank you.
well, we could just, we don't want to prolong this, the entire section.